secrets of successful zone entries in hockey. The goal of this paper was to predict sequences that led to goals with a high expected goals value. To do this, we used Sportlogic's dataset that contains 3 types of zone entries. These can be dump in, carry in, or passes. We further divided these into wide carry, middle carry, wide pass, short pass, and dump in. Wide carry and middle carry and dump in are pretty self-explanatory, and however, a wide pass was defined as a pass that where the puck moved more than half of the rink sideways, and a short pass where the puck moved less than half of the distance. We also divided the rink into these 5 areas. The first one, number 1, is upper wide. Then we have upper middle, middle wide, the slot, and behind goal crease. We can also see some statistics for the different zone entries. For example, what their percentage was and how many of them led to shots. To do this, we used a recurrent neural network with long short-term memory. On this picture, you can see how our model predicted the values compared to the true values.
Yes, so with this model, we could extract some results. So first of all, we extracted the sequences where our model predicted the highest expected goals values. And we also extracted the 100 sequences where our model predicted the lowest expected goals values. And first, with this information, we looked at some types of events and how often they occurred in these 2 types of sequences. And what we could see here is that a pass is slightly more often happens on an average for high expected goal sequences than for low. But the reception event happens a lot more often in the high expected goal sequences, which probably means, or which means that we have a lot more successful passes in the high expected goal sequences and we lose the puck less. We could also see that the average sequence length for high expected goal sequences is much longer than for low expected goal sequences. We also looked at the type of zones that we split the offensive zone in and how often events occurred in these type of zones. So what we could see here is that for high expected goal sequences, the middle wide zone has a lot more events for high expected goal sequences and also the slot zones. We could also see that for upper wide zone, that happens a lot more in low expected goal sequences than in high ones. And since upper wide is a zone furthest from goal, it's a zone you probably don't want to have too many events in. And further, we could use these results that we just gathered, and we then looked at all the sequences that had a shot in them. And for every entry, we looked at what we before could see was good events or good zones to be in. So we looked at shots in slot and how on an average often that happens for each type of entry. And we also looked at receptions in the middle wide zone and how often on an average that happened in every entry type. So what we could see for shots in slots is that happens most in the wide carry entry, but just slightly more than in the other entries. But the biggest difference that we found was for receptions in the middle wide zone, which happened a lot more frequently in the short pass entry type than for all the others. Since it happened 1.7 more times, it happened 1.7 times for the short pass entry, and only 0.59 on an average for the second highest, which was dumping. And here we could also refer back to the statistics we extracted from the data set, where we saw that the short pass actually was the entry type that led to the most goals. So to conclude, we could see that with more successful passes, longer sequences, and more events in the middle wide zone and slot, we could lead to a higher expected goal when a shot is taken. So that was all for our presentation. Thank you for listening, and we open up for questions.
You will notice that some projects were done by one person, some by several persons. So they were allowed to work together with up to 5 people. Questions?
I do have a question. So I didn't quite understand what a sequence meant in this situation.
That's okay.
Yeah. Those were the events following a zone entry to a zone exit.
And so, what are events like passes, hits, shots?
Yeah. So basically all events that we had in the data set.
So all the events that SportLogic provides.
Yeah.
Got it. Okay. Thank you. Yeah. That's what I guessed, but
it also was not until the zone exit. It was until the first, or not the first shot. It was until the last shot. Exactly. Until the last shot in that sequence.
okay. And so some of those events aren't really going to impact what's happening with the puck. Like it might be a hit off.
Yeah.
Or,
Yeah.
okay. Yeah. Okay. Thanks.
So you assume that you only had access to the raw data, not the video data, right?
Yeah.
So were you able to, for some of these sort of more promising things, look at the data and sort of infer what actually did happen, or build an intuition for, okay, this type of event is sort of a promising event, and then look at the data and infer what actually did happen in the game?
Well, we got a couple of sequences, or we extracted the top 5 sequences, which had the highest expected goal rate. But we didn't really look into what happened in the game. I guess those events were the things that happened.
Okay. So this was more sort of, okay, we take the data, we toss some things we think might have good value, lower value, and then see what the data tells us in some sense. Yeah. And in terms of what's your main, what should a team do based on what the data tells you from these 20 games?
I think the biggest thing was, it might be obvious, but that longer sequences is often very good. So if you have like longer attacks, power plays or some sort, it's I guess you could think that maybe counter attacks could be very lethal but with the data we had, we could see that longer sequences were almost always better.
So there is value to being a puck possession teams from these games. Okay, yeah, thank you.
I was just going to follow up and ask, do you know if the sequence lengths correlated with possession time?
We haven't checked that.
Yeah, no, it just occurred to me. Oh, longer sequences, probably you got the puck longer, right? Which kind of makes sense if you.
Did you try to split up power play and even strength and divide it to see if you could see the difference in the sequence part? Because of course you have longer sequence in power play than in even strength.
Yeah, not like particularly, but we had those. That was like one thing in the data that we had as an input to our RNN.
Okay.
So it took that into consideration when predicting the expected goals, but that was nothing that like we got a specific result of a power play specifically, but that was in the RNN.
Yeah, it's something that you could like further research, I guess.
Yeah.